The arc of the parabola y equals x squared from 0 to 1 is rotated about the y-axis. Find the area of the resulting surface. So here we can see this surface, and we're going to go ahead then and use our formula for the surface area, and that's going to be, we're going to integrate from 0 to 1, 2 pi. Now we are rotating this around the y-axis, and so our radius is going to be x. So 2 pi x, and then we have the square root of 1 plus, we need this derivative squared, that's 2x, quantity squared, so that's going to be 4x squared dx. Now as I look at this, I can see that this would work nicely with the u substitution. If I let u equal 1 plus 4x squared, then du is going to be 8x dx. And I have 2x dx, so I can take this and divide both sides by 4, and then we have 2x dx is going to be 1/4 du. So let's go ahead and do our substitution. We'll go ahead and move the pi out in front. Now we need to change our limits of integration to get them in terms of u. So if x is 0, u is 1, and if x was 1, u would be 5. And now we can replace our 2x dx with 1/4 du. We'll put the 1/4 here and the du here. And then we have the square root of u, so we're going to write that as u to the 1/2. So now we can go ahead and do that integration. So we have 1/4 pi, and we have u to 1 higher power, which is 3/2, and multiply by the reciprocal of that power. And then we're going to evaluate from 1 to 5. So let's go ahead and combine these. So it looks like we're going to have 1/6 pi, and then we're going to evaluate this. So we have 5 to the 3/2 minus 1 to the 3/2, which is just 1. And then we can simplify this just a little bit, because essentially this means the square root of 5 cubed, and so we could have one of the 5's there. So here we've got 1/6 pi, and then 5 square root of 5 minus 1. And we could leave it like that in exact form. We could put it in a calculator and get a decimal to approximate of 5.3 if we needed that.